Morning everybody, hope you're all okay. Welcome to Tuesday's Maths. Some great work yesterday because there were some tricky questions by the end of Power Maths, so well done to all of those of you who really persevered. Let's start with our Fab 4. Now, some of you got a bit confused with this when we looked at it in Power Maths. So think really carefully if those 20ths, if you're converting 20ths into a decimal, if they fall between two numbers. For example, if I looked at 5/20ths here, I would know that 5/20ths, 1, 2, 3, 4, 5 would be there. So it's halfway between 0.2 and 0.3. So halfway between is going to be 0.25. Use that knowledge and understanding to answer these questions. So pause the video, come back to me when you're finished. Off you go. All right, well done. Hopefully you've had a go. Here are the answers. 7/20ths is the same as 0.35 because it's halfway between 0.3 and 0.4. 19/20ths is 0.95. 0.45 is the same as 9/20ths. And 1 and 1/20th is one whole, and then it's 1.05 because you've got that halfway between a 0 and 0.1. Okay, hope you got on okay with those ones. Let's go to our main lesson today. Now, our WALT is that we're going to be writing fractions as decimals, continuing from yesterday. This is part 2. And we're going to try and make sure that we're really confident reading intervals on a number line and also using short division to convert fractions into decimals. So let's have a look at our Discover today. Now, we've got a teacher here showing a number line from 0 to 1. Now, whenever I see a number line with intervals like this, my first thing I do is count how many gaps there are and how many lines on that chart. Now, we need to know what decimal number the arrow is pointing to, and then it says label all the decimals onto the number line. Now, how are we going to tackle this? Let's have a think about the number of intervals. Now, that could be the spaces or lines that there are between 0 and 1. Now, in this case, we can see that there are 1, 2, 3, 4, 5, 6, 7, 8 gaps. That means that really we're going to be counting up in 8s to figure out what the decimals are on that line. Now, the arrow, if we can see, has counted up to 3 8s. Now, how are we going to write that as a decimal? This is quite tricky compared to what we've done over the last couple of days because we've looked at it in a way of changing our denominator into tenths, hundredths or thousands. Now, there's a bit of a problem with 8s because that can't multiply by anything to give any of those numbers. So I'm going to teach you a new method today. It's a good trick to remember from converting fractions into decimals. You can see here, let me just move my head so you can actually see that we've got 3 8s. Now, how do we convert it into a decimal? We use division, and we're going to divide the denominator into the numerator. What does that look like? Let's have a look on this slide. Now, 3/8 or 3 8s can be also thought of as 3 divided by 8, so we can use division. Now, some people get a bit confused because they're dividing the smaller number by the larger number. But if you think about it logically, it does make sense because it's a fraction of an amount, which is usually less than 1. So our decimal is going to be less than 1. So we are going to end up with a really small number. So the only way to do this, or the best way to do this, I find, is with a bus stop method. Now you can see on this diagram here, your 3 is inside the bus stop. So your numerator, your smallest number, goes inside the bus stop and it's being divided by 8. So that 8 is coming to visit the 3. How many groups of 8 we've got to think, can we get into 3? Well, we can't get any. So we have to put a 0 at the top, which you can see here. And then because we can't just stop there, what we're going to do is we're going to pass on this 3. Let me just get my pen. That's going to be a bit more helpful. Here we go. So you can see here, this 3 hasn't been used. So we've written into our bus stop, I've put a decimal point and onto my answer at the top. And then I've put a placeholder of a 0 next to it. So that means that this 3, which I haven't managed to divide into, I can pass on to that 0. So now I'm asking myself, how many 8s are there in 30? What do I multiply 8 by can I get to 30 or do I get close to it? Well, I know that 3 times 8 is 24. 4 times 8 is 32. That's too big, so it must be a 3. So I put a 3 at the top. I've got some left over from 24 to 30. I've got 6 left over. So I've written another placeholder in, and I'm passing that 6 that I've got left over to the next 0. And I carry on. Now, how many groups of 8 are there in 60? Well, I know that 7 8s are 56, so there must be 7 groups. Now, if it's 56, how many are left over? I've got 4 left over, so watch what happens next. So I've got 7 groups, which I put at the top here. That's how many I can fit into my 60. And I've got 4 left over, which I'm carrying on, and now having to put another 0, another placeholder onto there. So this is going to be my last step, because look, 8 into 40, that will divide equally. How many 8s go into 40? There's 5 8s in 40, aren't there? So I can actually then write my 5 there. Okay, so I've now said that if I do 3 divided by 8, I get an answer of 0.375, which is actually 3/8 as a decimal. So we've converted the fraction into a decimal by using division. Now you can do this for any fraction, even those ones that you can convert using tenths, hundredths, thousands. This method will still work. If you divide the numerator by your denominator, always you will find it and put it into a decimal number. So 3/8, what we've just learned here is that we've done 3 divided by 8, which gave us 0.375. So now we know that 3/8 as a decimal is 0.375, which the arrow was pointing to on our diagram. Now the question was actually asking us, can we label the whole line, so all the intervals? Now let's think which ones we don't need to do this method for, because we can use our knowledge and understanding that we already have. Now 4/8, I know that 4/8, if I simplify that, is the same as a half. Do you agree? Yeah? So look, here we go. 4/8, if I divide them both by 2, I get 2/4. Divide that by 2, I get a half. And we should all know now that a half is the same as 0.5. So that can already go onto our number line. We don't need to do any dividing by the denominator and numerator in this case. Now, which other ones can we use? Well, 2/8 represents 1/4. Which fraction represents 3/4? Can you think? If 2/8 is 1/4, 4/8 is a half, 6/8 is going to be 3/4, isn't it? So in a similar way, 2/8 simplifies to a quarter, and hopefully we should all know that a quarter is 0.25 as a decimal. If you're not so sure, you have a look here. A half was 0.5, and half of that is 0.25. Now, I would like you to now pause the video. First of all, I want you to think about 6/8 here. Can you how would 3/4 look as a decimal? So how can you use some of this knowledge from this slide to help you? And then for the remaining ones, 1/8, 5/8 and 7/8, have a go at putting them into a decimal number using what we learned on the previous slide. So you're going to divide the numerator by the denominator. So inside your bus stop is going to be that numerator dividing by 8. See what you come up with. Once you've done that, come back, unpause the video, and I'm going to give you the answers. Make sure you pause me now. Okay? All right, so well done. Hopefully you've been and had a go at this. Now, let's have a look if you've got the same answers. So 1/8, I got 0.125, 5/8, 0.625, and 7/8, 0.875. So if you've divided those numerators by the denominators, there should be your answers. Now, here we're going to look at something that can happen quite commonly when we're doing this method to explain what to do. So this is our think together. Danny is trying to convert 1/3 into a decimal. Which of these is the correct way to start the division? So first of all, here's 2. Am I doing 3 divided by 1 in this method here? I've got the 3 inside the bus stop. Or am I doing 1 divided by 3 here? Have a think. What do you reckon? Now remember, when we looked at this, here's our fraction. We're converting into a decimal. We're going to divide the numerator by the denominator. So the correct one is actually this one, isn't it? Because you've got your 1, your numerator, inside your bus stop, and your divisor is 3. You're dividing by 3 each time. Now let's have a look when we divide 1 by 3, what happens? So the first bit's already been done for us. So we don't need this one at all. We can just cross that off because that one is not right. So how many groups of 3 go into 1? Well, there aren't any, so we carry on with our 1. Next step, we are going to put a 0, and then we are going to think, sorry, let me start that again. I've confused myself with what I'm saying. So here we've done how many groups of 3 go into 1? There aren't any. So I carry the 1 and it makes this become a 10. How many groups of 3 are there in 10? Well, 3 times 3 is 9, isn't it? So I'm going to put a 3 at the top here, and then I'm going to think, well, I've got 1 left over, so I'm going to carry that on. I've put some more zeros to help me. But then what do you notice is happening? How many 3s go into 10? Well, there's 3, there's 1 left over. How many 3s go into 10? What would I write next? I would write 3, and I'd write 1 left over, and I'd need another 0. Now, what's happened here is that we've hit a wall where nothing is going to change. And if we carried on, we could keep going for hours, and it would just go 0.33333333333333 all the way along. And that's called a recurring decimal. The same thing happens over and over. Now you can just think, well, if I know it's going to be the same digit continuously, I could just stop. All right, I might do a few to check that that's going to be the case, but my final answer I would probably just write as 1/3 as a decimal is 0.3, or you could write 0.33. Both would be correct. Sometimes you might see a little dot drawn at the top of that 3, and that is the dot that symbolizes the word recurring, meaning repeating. So that number is going to keep repeating. So sometimes you might write it with a dot, sometimes people just decide to say no, it's 0.33, enough. Let's have a look at these ones as a go, so you can have a turn now. So write each of these calculations as a fraction and a decimal. So if it's 5 divided by 6, what would that look like as a fraction? So 5 divided by 6, which of those numbers is my numerator? Let's have a think. 5 divided by 6. So 5 is going to be my numerator because it's being divided by the 6. So that's the same as saying 5, 6. So inside my bus stop, I would write my 5 and I'm dividing it by 6. So I would get an answer of 0.833. Now you can see here the same has happened as on the previous slide. This is 3 recurring. So I could have got there and just done a dot because I know that I'm going to keep having 2 left over and a 0, 2 left over and a 0. Have a go, pause the video now and then have a go at the second one, 2 divided by 3 in the same way we've just done 5, 6. So first of all, what's the fraction? And then have a go at finding the decimal. Pause the video, come back to me in a minute. Okay, so hopefully you've seen that the decimal, oh sorry, that's my answer from last time. The fraction that we need here is 2/3. How does that look as your division? So you did 2 divided by 3, and again we got another recurring answer of 0.66666. We just kept going. So we could have said my final answer was 0.66, and again I could have written a dot at the top if I want to, but at this stage we don't need to worry too much about those dots. As long as you understand that sometimes the division could keep going and you don't have to, you can just stop. That's what's important here. Okay, so for today, pages 18 to 20 in your maths books, please. Now this is fractions as a decimal part 2. Have a go, see how you get on. If you get finished and done, have a go, come back to this, pause the challenge, and you can send me some challenges. A couple of you have been doing that, which I'm really pleased to see, so well done. And good luck. Any problems, send me some messages. Otherwise, I shall see you again tomorrow for some more. Well done, everybody. Bye-bye.